Hi everyone, hope you're doing well. This is a video to go over do now number 18 for our review for the Regents. Please don't forget to post this on Google Classroom for me, all the pages, so you get credit for the classwork. And we have another do now that's all about just mixed review. So a bunch of random things to go over. Definitely make sure you have your calculator. And here we go. All right, number 1. Determine if the product of 3 radical 2 and 8 radical 18 is rational or irrational, and explain. All right, so first we have to know that product means to multiply. So that's obviously really important. And you can do this right on the calculator. So we have 3 radical 2, make sure you move over, times 8 radical 18. And that's going to give us a nice whole number, 144. Okay, so we have 3 radical 2 times 8 radical 18, and that's going to give us 144. And obviously whole numbers, integers, anything like that, those are nice numbers. So that's going to be rational. So the product is rational. Remember, this is the sentence I taught you, okay? Because 144 can be written as the ratio of 2 integers where, or I think whose or where, either one of them is good. So where the denominator is not equal to 0, because we know fractions are our friends, fractions are good things, fractions are always irrational, but you can't divide by 0 because then you'll get an imaginary number. So hopefully you guys remember that one. All right, number 1 is done. Number 2, which table of values represents a linear relationship? Okay, so you always want to look for and to do the trick that I taught you, okay? So let's see. Yep, these all go up by +1, so we can do the trick, which is good. Okay, so remember the trick is if it's constant on the first try, then it's linear. Okay, so I guess I'll write that here. So linear is rate of change is constant on the first try. That's what we're looking for. Remember, you know, the other ones, quad, that's going to be your second try, and you'll have your cubic, that's going to be obviously the third try. And then if you have where it's never constant, that's usually either absolute value or that's going to be exponential. It's usually one of those. So let's see what we have. Okay, so this is +1, +3, plus, okay, so this is already no good. This is definitely not linear. If we keep going to check, it is constant on the second try, so this is actually quadratic. Okay, all of these go up by +1. Again, this is what allows us to do the trick. All right, I can already see that this one's no good. So this is 0.5, 1, 2, and 4, so that's no good. And then it's 0.5 again, 1 and 2, which is no good, and then 0.5. So this is going to be a nothing at all, a neither, and never. But if you look at these numbers, I do notice that they're doubling. So I automatically know that is exponential. Anything doubles, triples, anything like that, that's always going to be exponential. So this is going to be double, and our common ratio is going to be 2. All right, maybe it's C. So +1, +1, +1. And this is, let's see, +2, +2, +2, and +2. Yay, we found it. It is choice number 2. So now this one, I guess I'll just show you this one, might as well. +1, what do we got over here? We have 1, 1, 7, 19, and then we have 0, 6, and 12, and then we have a 6 and a 6. So this is actually constant on the third try, so our third try would be cubic. Remember, it is multiple choice, so technically you don't have to show your work. So you can also check this on the actually, you can do it on the calculator. You can also check on calc. So I'm going to put numbers into L1, L2. And that's by stat and then pressing number 1, which is edit. Then you're going to turn on your stat plot. Okay, so turn on the stat plot, and then we're going to press zoom, and then number 9, which is zoom stat, and that'll graph it for you. So I'll just show you really quick because all the X's are the same. So this will be quick. So stat 1, -1. Oh, we already have these in here. So -3, -2, 1, 6, and 13. I'm going to go to y equals, that is highlighted, so my stat plot is already on. Zoom 9, and I can see that's definitely a curve, and it's not linear. Okay, next one is 0.5, 1, 2, 4, and 8. So zoom 9, again, curve, definitely not linear. And then I'll just show you this one that is correct. -3, -1, 1, 3, and 5. Zoom 9, and there is your nice straight linear. So there is actually one more way I can show you how to do this on the calculator. It has to do with the correlation coefficient. So after you put the numbers into stat 1, okay, what we can do is go to stat, move over to calc, and then we're going to go to lin reg. So right now I have the answer in, and I'm going to show you what happens is that R, the correlation coefficient, is 1. So it's a perfect fit. That means that whatever you're trying out, which in this case is linear regression for us, that is a perfect fit, okay? If you were to look at the other ones, we'll do those ones really quick. So we have -3, -2, 1, 6, and 13. Okay, then we're going to stat calc. Again, we're testing out linear regression because that's what it's asking us. And we go to the correlation. This one isn't as high. It's pretty high, but it's not as high. So 0.958. Okay, if we go to the next one, stat 1, 0.5, 1, 2, 4, and 8. So let's look at that correlation. Again, we're going to lin reg because we're testing out linear regression, 0.94. So again, not as high as this one. This is a perfect fit. This is the winner. And I'll show you the last one. So it's going to be stat 1, change those numbers, -1, 0, 1, 8, and 27. Stat, move over to calc, number 4. And then we'll see that, again, it's not, you know, perfect like this one is. It's pretty high, but this one was, so out of all of them, the highest was this one. We tested linear regression on all of them. This was the winner because this was the one. So I guess I'll just add that to your notes really quick. So we can put... or check the correlation coefficients, which correlation coefficient, don't forget, is the R. And to do that, we put the numbers into stat, and then we did R1, but then we moved stat, move over to calc. Okay, then we chose number 4, linear regression, because that's what we were testing out. And we're going to look for the highest number. And again, 1 is perfect. That's going to be your perfect fit. So yeah, this is just another way to test it out. When maybe you forget how to do the long way, you have all these, you know, excellent calculator ways to help you out. So yeah, just another way to you know, get the answer. All right, 3. A polynomial function contains the factors x, x minus 2, and x plus 5, which graphs below curves into the okay. So this one's a little bit different than what you guys are used to doing. You're used to having to pick out the roots and then basically get it from there. This is backwards, okay? So they're giving you these factors. They're giving you x, x minus 2, and x plus 5, okay? They're giving you all this up here, and then they want you to solve it to get the roots, okay? So what we're going to solve for are the roots. Don't forget they're also called x-intercepts. They're called solutions, and they're also called zeros. So basically you just set these all equal to 0. Okay, so that's already going to be 0. This is going to be positive 2. And this is going to be -5 because we know it's always the opposite. Okay, right? So roots and binomials will always have opposite signs. Okay, so now we have to basically look for which one of these has these 3. So it's got to go through at 0. So this goes through at 0. This does not. So this one's out altogether. And this, okay. So now 2. Which one goes through at 2? Wow, these are tiny. Okay, this one so far has got both of them. So that's good. This does not go through. So this is the only one that is correct. So that is choice 1. I believe you can also check this on the calculator. Let's see. If I put this in, let's see if that works. I'm going to turn off my stat plot. Okay, so I'm going to put an x and then parentheses x minus 2 and then x plus 5. And let's graph it. Let's see. Okay, now I can't really see too well, so I'm going to press zoom and I'm going to press 6 to go back to the standard. And let's see. So it goes through 0, which is one of the answers. Good. 2, which was one of our answers, and -5, that was our other one. 1, 2, 3, 4, 5. Here you go. So you can also do this on the calculator too. Can check on calc. That's one good thing when you guys take the Regents, is that a lot of part ones multiplication can be done right on the calculator. So this one you can check on the calc also, or even do it on the calculator. All right, 4, function. Function, so we know this fancy sentence. Each element of the domain corresponds with one and only one element of the range. So what does that mean? Okay, so you're looking for where the x values do not repeat, okay, but the y values, those can repeat, and the Regents might, you know, make them repeat on purpose, so don't think it's wrong. All right, so those repeat, so that's no good. Those repeat, no good, 3/5. So that is our winner. C is our winner. Number 5. Morgan can start wrestling at age 5 in Division 1. He remains in that division until his next odd birthday, when he is required to move up to the next level. Okay, so he's going to be, so age, he's going to be 5. At age 7, he's going to move up. 9, he's going to move up, so on and so forth. And he's going to go to the next division level. So he starts at 1, then he's going to go to 2, 3, so on and so forth. So what we have here, these are your step functions. Okay, step functions. We haven't done this in a long time. So we're just going to kind of analyze and see what we have. So, okay, let's go with the first one. So at age 5, he should be at level 1, which is what he is. Good. And it goes until he gets to age 7. Now, notice this is an open circle. That means not equal to. So at age 7, he's not a Division 1. He jumps to Division 2, which he should be, right? Age 7, Division 2. That's correct. And then it keeps going and going. Then when he gets to age 9, that's when he jumps to the next one. So step function is always like, you know, the jumping up to the next portion. So this is actually the answer right away. So shows moving up on his next odd B-day. So this is correct, okay? This one's no good right away. You can notice, see, this is not even a function because it fails the vertical line test. Fails vertical line test. So that's no good. This one, this says at age 7, he's a Division 1. That's not good. He should be at Division 2. And this one is not even equal at all. He's equal to nothing at 7 or 9 or 11. So it doesn't even make sense. All right, moving on. 6, factor completely. So we know factor completely means more than one time. And we always look for what kind first? GCF. Good. So let's see, we have x to the third minus 13x squared minus 30x. So let's look for a GCF. Yes, definitely. So the GCF is going to be x. So x to the third divided by x is x squared. 13x squared divided by x is negative 13x. And that's going to give me negative 30. And let's see, it looks like we just have regular trinomial factoring, which I like to call MAMS. Okay, so chop down the first sign. Negative times a negative is a positive. So it multiplies to 30 and adds to 13, or multiplies to negative 30 and adds to negative 13. That's going to be 15 and 2. So that answer is here. All right, I think you can actually also check this in the calculator as well. Let's see, if we go to y equals, and we put x to the third minus, so let's get off of that, minus 13x squared. Then we have minus 30x, and then let's put in the answer, x, and then x plus 2, and then x minus 15. If we go to the table, they should be, oh yeah, look at that, they are matching. Perfect. So can check in table, which means you can actually probably even just get the answer right away in the table. So thank goodness for this calculator. It does everything for us. All right, number 7. Which pair of equations could not be used to solve the following equations for x and y? Okay, so looking for not. This is the one that I had taught you, kind of like a shortcut. You're basically looking for what you multiply by, okay? And what you are multiplying by is called the scale factor. So we're looking at the scale factors, okay? So check for the first one. So we're looking for which one is no good. So 4 to 4 stays the same. So that means you're going to multiply by 1. So everything here should be multiplied by 1. So 2 times 1 is 2. That's correct. 22 times 1. Okay, that's good. So that looks like it's multiplied by -1. So let's check this out. So 2 times -1 is -2. That's correct. -8 times, okay, so this one is good. We're looking for one which is not good. Okay, so let's try B. So it looks like the top one's all by 1, so that's good. So from here to here, it looks like it's multiplied by 2. So -2 times 2, 2 times 2 is 4. Okay, so this one's also good. That checks out. This one, it looks like it multiplied by 3. So 2 times 3 is 6. That's good. 22 times 3 is 66, so that's good. Here to here, it looks like we're multiplying by a -3, right? Negative for the negative is positive. 2 times 3, yep, that's right. So 2 times -3 is -6. That's good. -8 times -3 is 24. All right, so I'm assuming this is our answer. So let's see. So this times 2. So 4 times 2 is 8. 2 times 2 is 4. Okay, this is where it has to be the mistake. So this one's supposed to be multiplied by 4. So -2 times 4 is -8. 2 times 4 is 8. And there's the mistake right there. That should be -32 and not -8, because -8 times 4 is -32. All right, number 8. After performing analysis on a set of data, Jackie examined the scatter plot of the residual values for each analysis. Which scatter plot indicates the best linear fit for the data? All right, so I had taught you in the stats unit that like the best fit was going to be your random scatter. So random scatter or no pattern, that's what we are looking for. So if you look at the 4 choices, basically it's kind of like which one does not look like the other. It's going to be choice C. This is the one that has no pattern. Again, has the random scatter. And this is definitely an appropriate representation. Okay, if you look at here, you see the U pattern. Okay, so the U pattern means no good. Here you also see, right, just like this one, you see the U pattern. Again, the U pattern is no good. And then over here, we just see the upside down U pattern. So we're going to also say U pattern equals no good or not appropriate. No good slash not appropriate. No good slash not appropriate. Not appropriate. Okay, there's one other little thing that I wanted to say with this question, and that was this. And this is important for high school. That's why I want to go over it. So the stronger the correlation, so the closer the dots are to making that straight line, the smaller the residual. Okay, so I'll just kind of show that, I guess, like with pictures, or try my best. So if you have, dots that are pretty close together and pretty close to that straight line, you're going to have, a high correlation coefficient. So you're going to have 0.9. And that means that the distance that the dot is away from the line, it's going to be pretty small, okay? So this is going to be a small residual, okay? The numbers are very, very small. But here on this one, let's say you have dots all the way out here, and then kind of like all the way out here. So that's, more like your weak correlation. So they're not really close to the line. They're not really close to making a straight line. So this could be something like, 0.4. So this has a small correlation coefficient, and the distance, look how far away all these dots are from the line. So this is going to have a larger residual. Okay, so the stronger the correlation, so this one, meaning the dot is closer to making the straight line, is closer to the line of best fit, right, especially with a 0.9, the smaller the residuals. And again, residuals is the distance from the dot to the line. So these distances are going to be a lot smaller than these ones. These are going to be a lot larger. So that's really something that you want to make sure that you know for high school. All right, number 9. The graph of f of x is shown below. Which function can represent the graph of f of x? So this is definitely one that you guys are most used to, especially compared to this one over here in the beginning, number 3. This is the one where, they gave us the binomials. We had to work to get the roots and then figure out which one had the matching roots. Now it's backwards. One like, the one that I normally kind of give you. So right now we're going to identify the roots, which don't forget are also called the solutions, the zeros, or the x-intercepts. Good to know all that vocabulary. And that would be these dots right here, okay? Notice, by the way, it's not labeled. It doesn't tell you what to count by, so you just are going to assume it's 1 box equals 1 unit, okay? So this is x equals -4, -2, and 1. +1. Let me write them over here so you can see them. X equals -4, x equals -2, and x equals 1. All right, so now we're going to use those roots and we're going to work backwards to get our equation. So down here we'll write our roots, x equals -4. Then we have x equals -2 and x equals 1. Of course, they made it more difficult already because they made 3 roots. So this is our question where we work backwards. And remember, it's going to be the opposite sign. Okay, so if I tell you -4 here, that means in parentheses, it's going to be +4. Here, if I say -2, or we figure out the root's -2, it's going to be +2 in the parentheses. And here where it's +1, it's going to be -1 in the parentheses. So now we just compare and see which one matches, and there's no match. So this one is an even more difficult one. They're so mean, the Regents people. Okay. So what they did is that instead of having 3 factors to make it a little more difficult, they took 2 of the factors and they multiplied them to get a trinomial. Okay, they did double distribution. So basically you want to go from, there's 2 different ways you can do this. And there's also the graphing calculator way, which I'll show you as well. So basically we can go, it really doesn't matter which way, but I'll show it this way first. So for the first one, we have x plus 2, right? So that matches. So now we know we have x plus 4 and x minus 1. Well, if I take the x plus 4 and I multiply it by the x minus 1, x times x is x squared, x times -1 is -x, then +4x and -4. I'm going to combine those like terms. I'm going to get +3x and -4. So if I took those 2 and I checked them, I do indeed get that answer. So this one is going to be choice A. The other way you could have done it is you start from the top and you can actually factor out the trinomial and see if you get the factors that are here. So we know this is x, bring up a plus, a positive times a negative is a negative. What multiplies to 4 and adds to 3? That would be, I think, 4 and 1. And there you go. So you have x plus 2 and x plus 2, x plus 4 and x plus 4, and x minus 1 and x minus 1. So that's just another way to figure this out. Okay, so you've heard me say about the calculator. So really quick, I want to show you that. So can graph on calc to see which graph, I'm going to write /roots match. So that's going to be all about y equals. And then actually also in y equals can look at table for the roots as well. And that's going to be where y equals 0. So I'll show you both those. Remember, multiple choice, you really want to show your work. So use the calculator when you can. Okay, so let's put in our answer. So we're going to put in x plus 2 and then x squared plus 3x minus 4. And let's do the graphing first. So if you graph it, definitely see that matches, right? So we have 1, 2, 3, 4. So -4, -2, and 1. Those are all the correct roots. So that's would have been how you got your answer right away. And if you did it the table way, you're looking for these answers, -4, -2, and +1. You're all looking that it has the roots of 0, which it does, okay? So if we put our table here, -4 has 0, which we need. So -3, -2, -1, 0, and 1. -3 is 4. Then we have 0, which is correct for 2. -1, -8, and there's that other 0 that we need. So that's just another way to figure it out without actually doing all the work. So. All right, one more on this page. Number 10. Last week, a candle store received $355.60 for selling 20 candles. Small candles sell for $10.98 and large for $27.98. How many large candles did the store sell? Sounds like this is your favorite kind of question. I know you're also happy that we're doing this question. Okay, so it is your favorite LES and C. It is the question that I always write this. Money plus money equals money. And number plus number equals total number. So our total number is going to be right here. That's going to help us produce that. And then all of this money is going to go together. Money plus money equals total money. And that's going to help us create that one. So it's going to be systems of equations. So let's start with our legend. Let x equal, we'll do small first. So the number of small candles sold. And then we'll have y equals, it looks like a G, we'll have y equals the number of large candles sold. Okay, now our equation. So let's start with the yellow candle. So x plus y equals 20. So number of small candles and the number of large candles all together, 20 sold. Now let's do our money. So $10.98 for the small candle, so $10.98x. And then $27.98y, that's how much a large candle is. and total amount 355.60. So this is the one where you want to do the addition method or the elimination method, the high school might call it. So what you're going to do is you're going to take this coefficient, you're going to bring it up here. This is just the easiest way to do it. Take this coefficient of 1, bring it down. We have to make it negative because we want to make additive inverses. And now at this point, what we're going to do is we're going to do the distributive property. Okay, so we're going to have 1098x, 1098y, and 21960. I figured out a lot of these numbers forehand for you. So 1098x minus 2798y. And this one was negative 355.60. Okay, those are the additive inverses. Perfect, exactly what we need. So we're going to add them together. Remember, it says additive inverses. So you know you're going to add. Those cross out. That's going to give us a negative 17y and a negative 136. Divide both sides by negative 17, and you get y equals 8. Now, don't forget, you have 2 answers you need, okay? So I'm going to use my top equation just because it's easier. Plug in 8 for y, and then solve. And you get x equals 12. And you've been noticing these kind of questions come up a lot. The Regents people love these type of questions. It usually has to do with tickets. So, all right, solution. So x was, so the store sold 12 small candles and 8 large candles. Now this one was multiple choice. It just wanted the large. So we actually could have just stopped right here. But number 10 is B. All right, hopefully that LES&C wasn't too bad. All right, last page, almost done. Describe the following transformation from the parent function. Ooh, okay, this is a little bit different. So we have a negative on the inside. Remember, inside is always the opposite. So it says negative, so we're actually going to go, actually, let me write this. So inside is going to be left or right, and it's always the opposite. So if you see negative, that means right. So translated, 3 units right. Okay, so these ones are on the inside. And the plus, now it's going to mean to the left. So translated, 3 units left. Okay, so now when it's on the outside, the number, that's going to be up or down. And this is the one where we say it's going to be like the same. So when you see minus, it makes sense. It's going to go where the negatives are. So that's down. Okay, so this is going to be translated 3 units down, and this is going to be translated 3 units up. Okay, 12. Solve the following algebraically. So again, algebraically means no table. And I know you can do whatever you want. I know you could factor, you complete the square quadratic formula. I felt like we didn't really do a lot of quadratic formulas. So that's actually the one that I want to do right now. So you have to do it this way. Okay, so this one must be equal to 0. So we have 3x squared minus 13x equals 10. So I want to subtract 10 on both sides. I have to get it equal to 0. And it's okay that it is, the a is 3. That's totally okay. So a is 3, b is negative 13, and c is negative 10. So your formula, negative b plus or minus radical b squared minus 4ac over 2a. I wonder if a lot of you have that memorized by now. So the negative of negative 13 plus or minus, now be careful, you have to have this in parentheses here. There's stickler on the work, okay, as you know I am, so be careful. 4 times 3 times negative 10, don't lose the bottom, 2 times 3. Okay, the negative of negative 13 is going to wind up being a positive 13, okay? And then here, you have to make sure you use the parentheses in the calculator, or it's not going to do what you want it to do. So negative 13 squared, whoops, get rid of this, there we go, is 169, okay? If you don't put it in parentheses, what it's essentially going to do, okay, it's going to really negative 1 times 13 squared, which is not what you want it to do. Minus 4 times 3 times negative 10. Over 2 times 3, move it up here, 13 plus or minus, radical 169. Okay, so now careful here also, you do have double negatives, okay? Double negatives should give us a positive. So 4 times 3 times 10 is 120. And then over 6, so 13 plus or minus, that's going to give me 289 over 6. We'll work on that square root. How nice, they gave us a perfect square. So remember, when you take the square root of it, the radical sign does disappear. And then this is normally when we would split it up. So you have 13 plus 17 over 6. And then your second case is your 13 minus 17 over 6. So that's 30 over 6, which is 5. And that is negative 4 over 6, which is negative 2/3. So our answers are negative 2/3 and 5. So it's definitely good to know how to do the quadratic formula, especially if it says nearest tenth. That's what you're going to use. All right, on the last one, yay, lucky number 13, last one. The diagram below represents the first 3 terms of a sequence, where the terms correspond to the number of shaded squares. Okay. Assuming this pattern continues, which formula determines a sub n, the number of shaded regions in the nth term? So basically we want in general, okay? So you want to do explicit. That's what we're looking for. Okay, so since it says first, we have to say a sub 1. Okay, 12, 13, 14, 15, 16. All right, so right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 16. Okay, second term is a sub 2. All right, this is going to be 22. And the third term, that means a sub 3. 8, 9, 10, 11, 12. All right, so this is 28. Ooh, there's a lot of counting. Okay, so to do my explicit, we need a couple things, okay? Well, first we need to decide is arithmetic or geometric. So these are close to each other. So this goes up by 6. So this looks like it's going to be arithmetic. Okay, arithmetic, don't forget, is linear. So we need an a sub 1, and you need a common difference. A sub 1 is going to be 16, and that common difference was 6. So now we're going to plug it in to our formula. A sub 1 plus n minus 1 times d. A sub 1 is 16. Your common difference is 6. We're going to distribute to get 6n minus 6. Combine your like terms, and you get 6n plus 10. 6n plus 10. Good. All right, so remember this I had taught you was the same exact thing as like your y equals mx plus b. So the slope that you guys are used to, the m, that's also your common difference. And then this one is your y-intercept, right, which is a sub 0. So a sub 0, I guess I'll write it back over here. A sub 0 is 10. So if you go backwards and do the opposite, 16 minus 6 is 10. So that's kind of like another way you could, you know, kind of get these answers, because this is going to be just like this. So this is your slope or your common difference, right? And then this over here is usually your y-intercept, but it's a sub 0. So really you could, I guess, multiple choice, you could technically get these answers without doing any of this. Once you see the common difference, you know, and which they all have, right? They all have 6n. And then you have to just go backwards to get a sub 0, and 16 minus 6 is 10. It's the only one that has the 10 there. So the only other way you could really do this is you could put these numbers. So a sub 1 is 16, 2 is 22, and 3 is 28. You could put into L1, L2, which is, don't forget, your stat 1, and go to linear regression number 4 to get the equation. So number 1, just do this really quick. So 1, 2, and 3, 16, 22, and 28, and then go to stat. Let me write that, stat, and then move over to calc, and then go down to number 4. And there you go. You have your slope of 6, the y-intercept of 10. So that's it. The only other thing I can think of is maybe to do it this way, 6x plus 10. And then look at the graph and see which one gives you, like 1 is 16, 2 is 20. So again, one's a multiple choice. There's so many different ways you can figure it out. You technically don't have to show any of the work. So, all right, I think that is it for Do Now number 18. Hopefully it was not too bad. If you have any questions at all, please let me know. If not, just make sure you're posting this on Google Classroom so you get the credit. And yeah, that's about it. So have a wonderful day and take care.